Hey folks, welcome to my channel Number Pen. So today we're going to look at integral of e to the power ax sine bx dx, right? So we can definitely solve this using integral by parts. So I'm going to write down what my integral by parts states. My integral by parts tells me that integral of u dv equals uv minus integral of v du. Okay, right? So I will have to figure out what is my u and what is my dv. Okay. Now, without much of thinking, I'm going to choose my u to be e to the power ax and my dv to be sine bx dx. Okay. So I have my u, I have my dv. I need to figure out what is my du, which is nothing but a times e to the power ax dx, right? I hope you folks are with me. All I'm doing is differentiating e to the power ax, and then I have my dx here. And then when my dv is sine bx dx, my v equals minus of cos bx by b, right? So I have my u, I have my v, I have my du, I have my dv. So now I go ahead and apply integral by parts. So what do I get? My integral of e to the power ax sine bx dx, which is my LHS, becomes equal to uv, which is nothing but e to the power ax times minus cos bx by b. So that's the first part of my RHS. And then I have a minus of integral of v du, right? My v is nothing but minus cos bx by b, right? And then my du is nothing but a times e to the power ax dx, right? And so what is my integral of v du? My integral of v du becomes minus of a by b times e to the power ax into cos bx dx, right? And I know that my minus a by b is a constant, so I can pull that out of the integral. And then I already have a minus in my integral by parts identity, and therefore a minus into minus becomes plus. And then I get a by b times integral of e to the power ax dx times cos bx, right? Now I see that I have my RHS, but still my RHS is not in a very simple format where I can immediately conclude my derivative of the given expression, right? Looks like I will have to apply integral by parts once again. So I'm going to treat this separately. So let me go to the next line and choose what is my u and dv. So my u again will be e to the power ax, right? So let me write it as it is. And then my dv is now cos bx dx, right? So what do I need? I need my du, which is again a times e to the power ax dx, right? And then I need my v, which is nothing but a sine bx by b. So now you notice when I apply integral by parts for the second time, in v I get back my sine bx, and in my du I still have an e to the power ax dx, right? So let's plug it back into the integral by parts and see what do we get. So my uv now is nothing but e to the power ax times sine bx by b minus of integral of v du, which is nothing but integral of a by b times e to the power ax sine bx dx, right? So I can pull out my a by b because that's a constant. And then what I have inside the integral is nothing but e to the power ax into sine bx. Now you see we started off with integral of e to the power ax into sine bx dx, And when we apply integral by parts twice, somewhere I realize that I get back what I started off with, right? So if I call the original integral as say I, right? And then I rewrite what I have in my RHS post expansion, what do I get? Right? My first part remains as it is, minus e to the power ax cos bx by b. Then I have a plus a by b times. I have integral of e to the power ax cos bx dx, right? And which is what I solved for just now. And maybe I should highlight this in some color, say yellow. So I have plus a by b times my integral of e to the power ax into cos bx dx is what we solved for. I get e to the power ax sine bx by b, right? Minus of a by b times, and this is where I want you to watch this very closely, folks. I get a by b times integral of e to the power ax into sine bx dx, right? And I'm going to call this using a different color, right? Say green. And this is nothing but the original integral what I started off with, right? And I've called that I, right? So you can see what I have highlighted in green. So I can rewrite my integral of e to the power ax into sine bx dx as I now, right? I hope you folks are with me. And then now it looks like if I do a bit of rearrangement, I have an answer to the problem. So I get my LHS remains I, right? And then I rearrange my terms, what I have in the RHS, right? Now I'm going to move the I expression on the RHS to my left hand side. And what do I get? So this is what I get. I times b square plus a square the whole divided by b square. And on my RHS, I make b square as a common factor, and my numerator becomes ae to the power ax sine bx minus be to the power ax into cos bx, right? I know that I can cancel out my b square, and I'm left with I times a square plus b square equals ae to the power ax times sine bx minus be to the power ax times cos bx, right? And I know that I can pull out my e to the power ax because that is a common factor. My RHS becomes e to the power ax times a sine bx minus b cos bx, right? And my LHS is I times b square plus a square, and I'm left with I equals, I will put it in my x by y format. My x is nothing but e to the power ax times a sine bx minus b cos bx, and my denominator is b square plus a square, right? And then I have my constant plus c. So my answer to this problem is e to the power ax times a sine x minus b cos x, the whole divided by b square plus a square plus my constant c. So let me highlight my final answer in pink. So this is how we go about solving this problem. A lot of books will insist on you to remember this as an identity slash formula. I leave it to you. Doesn't matter if you don't remember, because we're going to solve a lot of problems of this type in the upcoming videos, and I wanted to show the thought process behind solving these problems, right? So I hope you found this content useful. Please do subscribe to my channel and support.